I'm Lexanan Raymunda and I'm going to discuss about prime factorization. What is prime factorization? Prime factorization is a way of expressing a number as a product of its prime factors. Prime numbers are the numbers that have only two factors. 1 and the numbers of like 2, 3, 5, 7, 11, 13, 17, 19, and so on. To make it short, prime factors is the process of factoring a given integer until the factor becomes a prime number. A prime number, as we all know, is a number that can only be divided by itself and 1 without leaving any remainders. Even composite number are all even numbers that aren't prime. But for now, let's concentrate on prime factorization. Let's take an example of the number 30. We know that 30 is 5 times 6, but 6 is not a prime number. The number 6 is expressed as 2 times 3. Since 3 and 2 are prime numbers, therefore, the prime factorization is 2 times 3 times 5. If we multiply 5 times 6, the answer is 30. So, 5 and 6 is under the 30. So, since the 5 is a prime number and 6 is not, we're going to multiply 2 times 3 and place it under the 6. Since 2 times 3 is, since 2 and 3 is a prime number, therefore 5 times 2 times 3 is the prime factorization of 30. What are factors and prime factors? Prime factorization is similar to factoring a number and considering only the prime numbers 2, 3, 5, 7, 11, 13, 17, 19, and so on, among all the factors. The factors that are the numbers that divide the original number completely and can be split into more factors are known as prime factors. Prime factors of a number are the set of prime numbers which when multiplied by together give the actual number. Also, we can say the prime factors divide the number completely. It is similar to factoring a number and considering only the prime numbers among the factors. For example, the prime factors of 6 will be 2 and 3. The prime factors of 26 will be 13 and 2, and so let's move on to the factors. Factors of a number are the numbers that are multiplied to get the original number. For example, 4 and 5 are the factors of 20. 4 times 5 equals 20. Whereas prime factors of a number are the prime numbers that are multiplied to get the original number. For example, 2, 2, and 5 are the prime numbers of 20. For example, here we have 20. So if to get the whole number 20, we need to multiply prime numbers. So the answer of if we want to get 20, we need to multiply 10 times 2. Since 10 is not a prime number, we're going to multiply 2 times 5 to get the number 10. And that's what prime factorization all about. Thank you.
After defining what is prime factorization as well as factors and prime factors, let us now proceed to the methods to find prime factorization. There are various methods to find the prime factorization of a number. The most common method used to find the prime factorization are given below. The first method is the prime factorization using factor tree method, and the second method are the division method of prime factorization. These two methods are used to easily find the prime factorization of a number. Now let's discuss the first method, which is the prime factorization using factor tree method. But before we start, let's have a short review regarding with prime numbers and composite numbers to easily understand the prime factorization. The prime numbers are natural numbers that have only one factor, 1 and itself. The example of prime number is number 3. The factor of 3 are 1 and 3, 1 and itself. Another prime number are number 11. The factor of 11 are 1 and 11, 1 and itself. So prime numbers are numbers that have only one factor, while when we say composite numbers, it is natural number that have more than two factors. For example, of composite numbers are number 6. The factor of 6 are 1, 2, 3, and 6. So the number 6 have more than two factors. Another composite numbers are number 14. 14, the factor of 14 are 1, 2, 7, and 14. So let's proceed in prime factorization using factor tree method. In factor tree method, the factors of a number are found and then those numbers are further factorized until we reach the prime numbers. Sa factor tree method, dito sa method na to, yung factors of the given numbers ay natatagpuan do or number are found. And those numbers are further factorized until we reach the prime numbers. It means that when we find the prime factor of, for example, of a given number, then those factors, if the factor of the given number is not prime numbers, and then we're going to break or factorize until it become a prime number. So pag may isang yung given number is kukunin natin ang prime factorization using factor tree method, mag-iisip tayo ng number na kapag minultiply natin pag minultiply natin together, ang lalabas is yung given number, and then if those factors are not prime numbers, already prime numbers, then we're going to factorize it until it become prime number. To evaluate prime factorization of a number using the factor tree method, follow the step given. So this is the step on how to use factor tree method. Step 1. Consider the number as the root of the tree that is at the top of the factor tree. So, for example, the given number, or we're going to find the prime factorization of 36. So, let's consider that the 36 as the root of the tree. So, we're going to write 36, for example, at the top of our paper or our other writing materials, and it is served as our root or yung ugat. Step 2. Then write down the corresponding pair of the factor as the branches of the tree. And then, we're going to 36, diba? 36, we write 36, and then we're going to think of two numbers or factors of 36 that when we multiply that the product will be 36. So the pair factors of 36 or the factors of 36 are 12 and so we're going 36, we're going to draw a line under the number of under the 36, and then we're going to write 3 and 12. Isusulat natin yung mag-drawing tayo ng guhit sa baba ng 36, and then sa baba ng guhit susulat natin ang number na 3 and 12. Step 3. Factorize the composite factors that are found in step 2, and then write down the pair of factor as the next branches of the tree. So, we're going to identify on the factor that we have written under the 36 or dun sa baba ng guhit na sinulat natin, we're going to identify if it's that number is a already prime number or composite number. So, under ng 36, nag-guhit tayo ng parang branches, nag-guhit, dalawa, and then sa baba nun, 3 and 12, which is the factor of 36. And then, we're going to identify if those factors are already prime na. If it's not, we're going to factorize or break that number until it becomes prime number. Number 3. So, ang factor is 3 and 12. 3 is already a prime. So, okay na yan. Pababayan na lang natin siya dyan. And then, we're going to move to the 12 number. So, 12 is not a prime number. It is a composite number. Because 12 have more than 2 factors. So, we're going to break that 12 or factorize 12, the number 12. The number 12. So, 12, let's think, like in the step 2, we're going to think two numbers when we multiply, the product will be 12. So, the factors or the factors of 12 are 4 and 3. So, we're going to write another line which is serve as a branches of our factor 3, and then under those lines we're going to write 4 and 3, which is the factor of 12. Step 4. Repeat step 3 until we get the prime factors of all the composite factors. So again, we're going to identify if it's the factor that were written under the given number is already a prime or composite. So 4 and 3 is the factor of 12. 3 is already a prime number, so i-stay po na lang natin siya dyan. And then let's move to 4, number 4. 4 is a composite number. It is not already a prime number because 4 have more than 2 factors. So we can factorize it. So we're going to factorize the number 4 until it become a prime number. So for the factor of 4 is 2 times 2. 2 times 2 is equal to 4. So we're going to write another line, branches that serve as branches of our factor 3, and then write 2 and 2 at the end of that line. So 2, the number 2 is already a prime number, so the process will end there, and we already find the prime factorization of the number 36. So we already have 3, 2, 2, and 3. So we're going to write it as 36 is equal to 2 times 2 times 3 times 3. Or we can write it in an exponential form or exponent as 36 is equals to 3 or 36 is equal to 2 squared times 3 cubed. So that's how we're going to use a factor 3 method.
Good day everyone, my name is Haley Joel Bellarmino from BSIT4B, and today I will going to discuss the division method of prime factorization. So here are the steps on how you can get the prime factor of a large number. So dito, step 1, divide the number by the smallest prime number such that the smallest prime number should divide the number correctly. So sinasabi dito, kailangan yung gumamit ng pinakamababang o pinakamaliit na prime factor para mas makuha niyo yung number na gusto niyo. Step 2, again, divide the quotient of step 1 by the smallest prime number. So ulit-ulitin lang natin yon hanggang step 3, hanggang sa lumabas yung number 1, yung hindi na siya pwedeng i-divide. And then finally, multiply all the prime factors that are the divisor of the division. So, pag nakuha nyo na yung sagot na number 1, kukunin na natin yung mga lumabas na prime factors doon sa ginawa nating steps from 1 to 3. So, dito, may example akong nakita. So, ito yung gagamitin for today. So, ito nakita ko sa Ang ginamit niyang method dito is 3 method. So, bakit siya tinawag na 3? So, Halata naman, mukha siyang tree, Christmas tree. So, ganun. So, ang number natin dito is 54. So, ang ginamit niyang numbers, dinivide niya yung 54. So, ang nakuha niyang number is 6 and 9. So, 6 and 9, pwede pa siyang i-divide, diba? So, ayun, pinaliit pa natin siya. Yung 6, i-divide natin siya sa 2. So, ang lumabas dun ay 3. And yung 9, divisible pa siya sa 3. So, 3 divide 3. So, dito sa baba, ang lumabas is 2, 3, 3, 3. So, ayun, hindi na siya pwedeng pababain pa or i-lowest term pa kasi max na yan. So, ayan, nakuha na natin yung prime factors nila which is 2, 3, 3, 3. So, ayun. So, para maalaman natin kung tama ba yung factorization na ginawa natin is imumultiply natin silang apat, yung 2, 3, 3, 3. So, kapag tama yung sagot doon, ibig sabihin tama yung pagkuha natin ng prime factors ng number 54. So, ang ginawa niya dito is 54 is equals to 2 times 3 times 3 times 3. So, ayan. Pag minultiply natin siya is 54 nga ang kakalabasan niya. So, which is tama yung pagkuha natin ng prime factors ng 54. So, meron pa isang method na nakita sa Google which is the ladder method. So, ayun, kaya siya tinawag na ladder method is mukha naman talaga siyang ladder. Ayan. So, ang ginamit naman niya ditong lowest prime factor is 2, 5, 5. So, i-divide niya yung 50 sa 5. So, ang lumabas doon is, di ba, pag dinivide natin yung 50 sa 5, 10. Tapos, pwede pang, yung 10, pwede pa ulit siyang pababain. So, i-divide siya ulit sa 5. So, ang lumabas doon is 2. Ayan. Tapos, yung 2, pwede pa siyang i-divide sa 2. And, ayan, nakuha na natin yung number 1. So, tigil na tayo, na-stop na. So, ang prime factor ng 50 is 2, 5, 5. Or pwede natin siyang gawing 2 times 5 squared. So, ayun. Pag minultiply natin yung 2 times 5 times 5 is 50 yung kakalabasan niyang sagot. So, ayun. Hopefully, may natutunan kayo sa aking i-discuss for them. Thank you.
So now we're done talking about the methods of prime factorization. Let's move on to the applications of prime factorization. And there is a wide range of properties of prime factorization, but these are the two most important applications. So the first one is cryptography and the second one is HCF and LCM. So let's start with cryptography and prime factorization. So cryptography is a method of protecting information and communicating cryptography through the use of codes. Prime factorization plays an important role for the coders who want to create a unique code using numbers that is not too heavy for computers to store or process quickly. So prime factorization is actually a commonly used mathematical problem which is often used to secure public key encryption systems. So a common practice is to use very large semi-primes. So yun yung result ng multiplication ng two prime numbers as the number securing the encryption. In order to break it, they would have to find the prime factorization of that large semi-prime numbers. And also, factoring numbers is a computationally difficult problem. And once you start dealing with very large numbers, it can take computers days, months, years, or even centuries to solve. So, sa atin, kung manually ko-compute natin, apakadali. Pero, pag si computer yung magsosolve, it may take months, days. Kaya, yun yung kaya prime factorization usually ginagamit for encryption kasi nga mahirap siyang ma-break. And there is no easy shortcut for factoring numbers. Usually, it is a trial and error process. And also, it is easy for smaller numbers. However, once you begin dealing with very large numbers, the amount of possible numbers you need to check against each other becomes so large that even modern computers are not able to do in a reasonable time frame. So that's the reason why cryptography and prime factorization are both connected, and that prime factorization is important for cryptography. So the next application is HCF and LCM using prime factorization. So to find the HCF and LCM of two numbers, we would need to use the prime factorization method, and we consider the following. HCF is the product of the smallest power of each common prime factor, while LCM is the product of the greatest power of each common prime factor. So when the prime factors of two numbers are known, they can be compared to calculate HCFs and LCMs. This can be a more efficient method than listing the factors and multiples of large numbers. LCM stands for least common multiple. So the least common multiple of a number is the smallest number that is the product of two or more numbers. So the LCM of two numbers can be found out by first finding out the prime factors of the numbers. And as for the HCF, it stands for the highest common factor. The highest common factor of two numbers is the highest possible number, in which it divides both the numbers completely. The HCF of two numbers can be found out by first finding out the prime factors of the numbers. So it is included in here. So actually for the HCM and LCM, in order for us to find them, it is included in the previous discussion by RJ, which means that we would need to use factor 3 and division method in order to find the HCM and LCM of two numbers. So that's how they're connected. So that's the end of our lesson. Thank you for listening.